This is going to be a very short one, but as we're heading off into the world of transformations, translations, use of the complex plane as proxy for the XY plane, I stumble on a few things with regard to who takes what, how, when, and where when it comes down to complex numbers. And what it came down to is within one of my favorite spreadsheet apps, which is Google Docs, it did not have complex numbers, which sent me to one of my favorite programming places or graphics places, SketchUp Ruby. And it turned out that Ruby, the most recent, has complex functionality for complex numbers, but the one that SketchUp uses, which is 1.8 point something, does not. Into Excel, of course, Excel had it, and of course the calculator had it, and it got me thinking about when will this ever all shift? Especially when you look at the calculator, which is on the left here, the TI-83, and the fact that both pi, e, and I, they're all second functions. They're not placed at a very easy spot to get. That said, the great thing about the TI calculator is that in fact it has functionality for complex numbers. And you'll see later on that when you're dealing with complex numbers, one of the beautiful things about them for dealing in kind of the faux XY plane, it being the complex plane, is that if you add a vector, which essentially is what a complex number is, you will be translating. If you multiply, you will be either rotating if you're if the coefficient next to e is 1, you're going to be just rotating, and if the coefficient next to e is greater or less than 1, you will be scaling and or rotating. So we see that it's possible there, dealing with all the great things of complex numbers. We see it's possible then in an Excel spreadsheet, and I'm just going to show here E and point out that like with matrices, you have to do the functions as letting it know it's an imaginary number. So for instance here, we defined basically a complex number, 5 plus 5, which would be 5 plus 5i, which would be a line that's added 45 degrees to the real axis, and then another number using the function complex, which would be in fact 90 degrees up. But the multiplication or the sum, you see the sum here, we cannot just use add. We've got to let it know it's an imaginary sum, and we have to let it know it's an imaginary product. And then there are a lot of other functions as well, but they all begin with the im. So I'll do that again, equal im, and you should probably start to see the function here that they're all going to begin with the im. So im, product, prod, etc. That's how they're all going to tend to work. So there's the dog in the background. Now finally we go, of course, back to Wolfram Alpha, and of course we start with the Euler equation E. And remember that we're going to have to get very good in this world at keeping extremely good sense of keeping our parenthesization correct, so we don't stumble into areas we really don't know what's going on. Though you will see that once you kind of get this, it will not be bad. And once again, you remember, you'll start to see that you're going to always see in Wolfram or some of these higher math engines the series representation as well as the standard representation. So you've been through all that in math, and so let's just try this right now. Let's put one number in, and this of course is e to the pi, and we're going to go pi slash 2.0. So this should turn something 90 degrees. So let's put another number in front of that. which might be something 4 long, 4 plus I. So we're going to try to mix, right? We're going to try to mix that one number and the other, one imaginary number and another imaginary number, and see what it does for us. So see how it does with that and what it does with it. It actually gives us an input, and it should have actually 4 plus I, and then it rotated 90 degrees, and so you see it did come out and do it correctly. So once again, Mathematica, as we would expect, and Wolfram is going to do it as well as anybody else as we begin this kind of slow, methodical, good addiction to the higher math products available on your phone, and what they're going to tend to bring back now is some of these simple, I would say, elegant mathematical methods to do simple things. So as we've talked about before, you can do a lot of graphing on your calculator. The calculator becomes this incredibly good thing to do 2D and even faux 3D. Now we're going to be stuck between Excel and Google Docs, and we can watch now how long it takes for Google Docs to use complex numbers. I would expect that it will be pretty responsive, and we can realize that one can do 3D work with complex numbers quite easily by dovetailing or daisy chaining them once and then again, but we will stick with then standard trig. If you remember the other form, I'm going to finally show you that in this, put the other form of e to the I pi. E, remember, Euler's number, Euler's equation, to the open parentheses I pi. When you see the other form of that, you can start to recognize why this all works. So the other form of this equation is not given here, but would be cosine of theta plus I times the sine of theta. Right, so last thing is we're here. Let's look real quick as I finish this one out at the Wolfram Course Assistant apps. Incredibly good stuff for every course. So at least for music theory, algebra, and calculus for the phone, pretty wild, cool stuff coming out of Wolfram Alpha. So the march to an increase in adoption continues. Thanks for listening.